Hi everyone. Now we are going to see about code converters. What is meant by code converters? Code converters is a combination circuit which is used to convert one coding system into another form of coding system. So for example, if we are going to convert a binary value into a octal value, we are going to use the code converters. So one binary code value is converted into another equivalent code value by using the code converters. These are all the types of converters. We are going to convert binary to gray code converter, then gray to binary code converter, binary to BCD, BCD to binary, BCD to XS3, then XS3 to BCD converter, then BCD to 7 segment converter. In the case of binary to gray converter, it converts the binary numbers into gray code. In the case of gray to binary code converter, it converts gray code into binary numbers. In binary to BCD converter, it converts binary number into binary coded decimal values. In the case of BCD to binary converter, it converts BCD numbers into binary forms. In BCD to XS3 converter, it converts BCD code into XS3 code. In XS3 to BCD converter, it converts XS3 back into BCD. In BCD to 7 segment converter, it converts the BCD input signal into a decimal digits for a 7 segment display. These are all the types of converters. Next, we are going to see about binary to gray converter. In binary to gray converter, here it converts the binary value into a gray code. Here we are going to use exclusive OR operation for this conversion. Here it keeps the MSB bit as such. Here it keeps the MSB bit as such, and it performs the XOR operation with the neighboring bit, immediate left bit. Here it performs the XOR operation with the immediate left bit, and it forms the output. So for example, here the one is kept as such. Here then it performs the XOR operation with the neighbor left bit. So 1 with 0. So the output is 1. Next, here the 0 is again, it performs the XOR operation with the neighbor bit 0. Then the output is 0. Here, then this 0 is performs the XOR operation with 1 and the output is 1. Here, then this 1 is performs the XOR operation with the neighboring 1 and the output is 0. Then this one performs the XOR operation with 0 and the output is 1. Likewise, it converts the binary code value into a gray code by using exclusive OR operation. In this slide, here we have converted the binary inputs value into a gray output values by using the same method from 0 to 15. So in this truth table, they have converted the values of decimal values from 0, corresponding binary values 0, 0, 0 and the equivalent gray values. Likewise, it converted the values from 0 to 15 by using the same procedure. Next, we are going to form the K-map. So, for Z0, we are going to form the K-map. The value is B1 exclusive of B0. Next, for Z2, we are going to form the K-map. Then, the output is B2 exclusive of B3. Next, for G1, we are going to form the K-map and the output is B1 exclusive of B2. Next, for G3, the output is B3. So likewise, we got the output for the G0, G1, G2, G3. So for the corresponding binary values, we got the gray code values. Next, we are going to form the circuit. So based on the expressions from the K-map, the circuit diagram is formed by using the XOR gate for the G3, G2, G1 and G0. Next, we are going to see the gray to binary converter. So To convert the gray code to binary code, we are going to form the procedure as like the previous procedure, but small change here. We are going to keep the MS bit same. Then we are going to perform the XOR bit between the newly formed binary bit with the neighbor bit. So we are going to keep the 1 as such. Then we are going to perform the XOR operation. 1 with this 1. What the value of XOR function? 1 with 1 we got 0. Then we are going to form this new bit with the XOR function. So the same thing we are going to repeat here for the remaining bits. So we will get the gray code into binary value. First, the first bit is keep it as a MS bit, then 1 with the second bit, so the value as 0. Then third step, we are going to form the binary bit 0 with the gray bit 0. The XOR function is 0. Then third bit 0 with the fourth bit 1. So the XOR function value is 1. Finally, the binary equivalent of gray code is 110 is 1001. So likewise, we need to convert all the binary gray code into binary values. This is the truth table for the gray code to binary values. Here the decimal values for equivalent decimal values of zeros 0 to 15. So for these decimal values, the gray code values and binary values are seen in this truth table. So here next we are going to see about the K-map simplification for the gray to binary converter. So likewise, binary to gray converter, here also we have performed the gray to binary converter. So for the K-map simplification, for B3 equal to G3, same, B2 is equal to G2 plus G3, then for B1 equal to G1 plus G0, then for B0 is equal to G0 plus G1. The same thing which we have done in the binary to gray conversion, we are going to do the same for the gray to binary conversion. Then finally we are going to draw the circuit diagram for the gray to binary converter. So here G0, G1, G2, G3 are the inputs, B0, B1, B2, B3 are the outputs. So by using XOR gate, we drawn the circuit diagram for the gray to binary converter. Next, as a summary of this today's video lecture class, we have discussed about the what is code converters, what are types of code converters. Then in that code converter, we have converted the binary to gray code, and then gray to binary code. We drawn the truth table for the binary to gray converter, then K-map simplification, then circuit diagram, and also for the gray to binary converter, truth table, K-map simplification, then circuit diagram. So likewise, we are going to convert all the binary values into either BCD values or XS3 values, then or as a 7 segment decoder values. So this is the overview of the code converters. Thank you.